For today, we're going to do some problems that build off of what we have been studying, and it's solving polynomial inequalities. It's part of section 2.8. So, for example, if we had x squared plus 5x plus 4, that's a polynomial. If we set that equal to 0, like this, that means we want to solve it for the zeros. But sometimes we want to know, when is it positive, when is it negative? And we could do this with any type of polynomial. And it really only requires what you already know. Essentially, what you're going to have to do is find the zeros. So the first step is going to be to find the zeros of the polynomial. And then there's two ways to attack these problems. You can either sketch it like we've been doing. So you can sketch using the end behavior and the zeros, which I'll model first, or you can do what's called a sign chart. And essentially using a sign chart just means pick numbers in between the real zeros. And you'll know if the polynomial will be positive. If the y value comes out to be positive, it's a positive area. If the y value comes out to be negative, it would be a negative area. And I'll show you that. So when I say find the zeros, it's the real zeros. We don't need the complex zeros because we know it doesn't cross. So let's take this one onto the next slide. And if we say x squared plus 5x plus 4, and let's say we want to know, when is this greater than 0? So step one is we're going to have to find the zero. So on a quadratic, we can try to factor it or use a quadratic formula if it's not factorable. But that one's factorable. So the first thing we do is we solve for the zeros. So you set it equal to 0. If it was a higher order polynomial, you'd solve for the zeros like we've been doing with the p's and the q's. And then we can say that x would equal -4 and x would equal -1. And so we would look at our graph and we'd put our zeros at -1 and at -4. And then the attack from there is, since we want to find out when is this positive, we can either picture it. So we know that the leading coefficient on this one is a 1. So that means the right side's going to go up. Since it's an even degree polynomial, the left side's going to go up. And this is going to come down and do something like this. Since the multiplicity of each of these zeros is 1, it crosses at each zero. So it's going to look something like that. And so we can see that in this region it's greater than 0, and in this region it's greater than 0. So we would say that the answer, the solution to this problem would be from -infinity to -4, union with -1 to infinity. That's when our function is greater than 0. If we had wanted to know when is this function less than 0, we would have done the same thing. If we said x squared plus 5x plus 4 has to be less than 0, then we would have done the exact same thing, picked the zeros, but this is where it's below 0, the value of the function is negative, and so in that case we would have said from -4 to -1 would have been our answer. Now the only thing that we do want to remember also is, let's say that instead of less than 0, we said less than or equal to 0. Well, then we would have to include the zeros, and then that would make these brackets instead of parentheses. And that's how we're going to do all of the problems for tonight. If you're having a hard time, you can graph them on your calculator, but the goal is you're going to find the zeros, and then you're going to either sketch it or do a sign chart. So now let me model a sign chart. Let's take one that's a little bit different. It's already factored for us, and some of the homework for tonight will look like this. They're a little bit easier because you don't actually have to factor them. So we're looking for this polynomial function, and when is it greater than 0? Now, this polynomial function has a degree. This is going to be an x cubed. This is an x squared, and this is going to be an x to the 4th. So this is 3, 4, 5, 6, 7, 8, 9. So this is a degree of 9. And the leading coefficient is going to be 1x times 1x times 1x times 4x squared times x to the 4th. That's going to be the leading coefficient. So our leading coefficient is going to be 4x to the 9th. So it's a positive. Now, what are the zeros? Well, if we look at the first factor, we know 1 0 is x equals minus 2, and it has a multiplicity of 3. That means it's odd. It's going to cross because the multiplicity is odd. We're going to look at the second one in a second. Let's do the third one. X equals 9 is the 0. It has a multiplicity of 4. It just touches the axis. It does not cross. Now let's look at the zeros for the next one. 4x squared plus 1. If we set that equal to 0, we would get 4x squared equals minus 1. X squared equals minus 1/4. That means that the roots for this are going to be non-real. So it's not going to touch the axis for those roots. We don't have to worry about non-real roots when we do these. So now let's draw this axis out, and we'll say we have -2, that's a 0, and 9. And then we have 2 non-reals. Now at -2, there's an odd, so it's going to cross at the -2. At 9, the multiplicity is even, so it's going to touch at the 9. And the leading coefficient is positive, which means beyond the 9 it's going up. The degree is negative, so on the other end it's going down. Now we don't know what's happening in between these, but we know it's going to cross at the -2, and it's going to touch at the 9. There's going to be a bump in there somewhere. It doesn't matter where, because we're just looking for inequalities. So that's the visual of this. But let's do a sign chart. If you wanted to do a sign chart, what you do is you identify your 2 zeros. You don't worry about the graph. And you just pick a number to the left of the 0. So we say -3. And you would plug -3 into your function. So we'll go ahead and plug -3 in up above, and I'll do that in blue so you can see. So we would say -3 plus 2 cubed. That's -1 cubed, so that's -1. And let me just erase this for a minute. Okay, so this becomes -1. Or you can just say negative. And then we're going to put 4 times -3 squared plus 1. Okay. So -3 squared is 9. 9 times 4 is 36. So this is going to be plus 37. Now you don't actually even need to come up with what the number is. You just need to know that this parentheses is going to give you a positive number. This parenthesis is going to give you a negative number when I plug in -3. Now if I plug in -3 here, -3 minus 9 raised to the 4th, well that's -12 raised to the 4th. Anything raised to an even is positive. So that means when I plug -3 in, I get negative times positive, that's negative. So when I plug in -3, that's to the left of the 2, I'm in the negative region. That makes sense. So doing a sign chart, you would just plug in a number. So let's plug in 0. Okay, so I'll do a different color and you can see what I mean. Let's do orange. So if we plug 0 into our function, we would have 0 plus 2 cubed times 4 times 0 squared plus 1 times 0 minus 9 to the 4th. Well, 2 cubed is going to be a positive number. 1 is a positive number. Minus 9 to the 4th is a positive number. Positive times positive times positive is positive. That's how we use the sign chart. That means when x is 0, we get some positive value. So the answer to this, you can either do it graphically or by a sign chart, picking numbers to the left and right, is anywhere from -2 to 9. So the answer to this is -2 to 9, not including those two. Okay?